All right, class, I'm back. So we're continuing on. The next one is solve the equation for x. Notice this is a simple linear equation, relatively simple. All right. I want to point out you could notice that this is x minus 4 and that's x minus 4. That, if you notice it, will save you some time because they are the same. So I'm going to use that fact and add. I'm going to begin by adding 3x minus 4 to both sides. Okay. Those sum to 0. We are left with 5 equals, now we have 2 plus 3 right here, just like with variables. 2 plus 3 is 5. And that's x minus 4 minus 15. Next step, now this is a simple linear equation. I would drop opposites, add 15 to both sides. You get 20 equals, 5x minus 4. I recognize that I can divide by 5 both sides. And I get 4 equals x minus 4. So I get x equals 8 as the solution. I use the fact that we had the same thing inside the parentheses here and here. If you don't have that, then you would distribute the negative 3, makes it longer. Distribute the 2, combine like terms, and then solve it from there. All right, the next one is solve the equation for x. All right, so to solve this, notice we have an absolute value. The goal to solve this is you have to get the absolute value by itself. So we're going to denude this left side. I am going to begin by adding 7 to both sides of the equation, and we have 4 absolute value of x plus 5 equals 12. I am now going to divide by 4 because I want to get the absolute value by itself. So now I have the absolute value of x plus 5 equal to 3. Now I'm going to use the fact that x plus 5 has 2 possible outcomes. The inside, this right here could be negative, right? Because when you take the absolute value, it makes it positive. So one option is that x plus 5 can equal a negative 3. And then the other option is that x plus 5 can equal a positive 3. This leads us to 2 solutions. X equals negative 8 from subtracting 5 here from both sides, and x equals negative 2 from subtracting 5 from both sides. And those are the solutions. And now is question 12. Notice question 13, solve the equation for x by graphing. Now it's a quadratic. I have 2 of these. Not sure why you only have 1 on the test. I think this is where I hiccuped a little bit on examples. So to do this, we have to graph both sides of the equation. So on one side, I'm going to begin by graphing y equals x minus 5. And then on the other side, I'm going to begin by, or not begin, but I'm going to graph y equals x minus 4 squared minus 3. Here's our grid. I'm going to begin with the black graph. So it's a parabola shifted to the right 4, down 3. So that means it would have been here at the origin, but now it's to the right 1, 2, 3, 4, and down 3. 1, 2, 3. That's where the vertex is. So to the right 1, 2, 3, 1, 2, 3, 4, down 1, 2, 3. There it is. It's a happy graph, so I'm going to go 1 to the right. 1 squared is 1. We go up 1 on both sides. 2 to the right. 1, 2. 2 squared is 4. Up 4. 1, 2, 3, 4. 4. 3 to the right. 1, 2, 3. 9. 3 squared is 9, so up 1, 2, 3, 4, 5, 6, 7, 8, 9. And we have one symmetrical on the other side. I probably, since I want you to do this, I probably should have drawn the axis of symmetry. All right, to make sure I'm in the right locations. All right, then I just connect the dots. So I didn't take. All right, there's the parabola. Now for the purple graph, it's y equals x minus 5. It's a line, 1, 2, 3, 4, 5, has a y-intercept of -5 and has a slope of 1. So we go up 1 to the right 1, 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 up 1 to the right 1. So it looks to me that if we were to solve this graphically, you would see that there are two solutions. It's where the two graphs intersect. So one solution would simply be this point, which is at 1, 2, 3. It's at x equals 3, y equals -2. So it's at 3, -2. The other solution would be 1, 2, 3, 4, 5, 6, 1. There you go. Notice, you have to show the intersection points on the grid provided. Okay, the next one's very similar to the one I just did. Same idea. It's a quadratic, x plus 1 squared, so I'm going to focus on this side first. So it's x plus 1 to the left 1, down 1, 2, 3, 4. There's the vertex. Now we go over to the right 1, up 1. I go both sides, right 1, 2, 3, 4. Let me restate that. Right 1 squared is 1, we go up 1. Right 1, 2, 2 squared is 4, we go up 1, 2, 3, 4. We go to the right 1, 2, 3. 3 squared is 9. We go up 1, 2, 3, 4, 5, 6, 7, 8, 9. And we do it to the other side also. And then we just connect. I didn't hold it. Okay. Now the other is just a straight line, 1, 2, 3, right there. And we go up 1 to the right 1, up 1 to the right 1, up 1 to the right 1. We go down 1 to the left 1, down 1 to the left 1. And our line looks like this. And we have 2 points of intersection. We have that point and this point. So the two solutions are -1, comma, 1, 2, 3, 4, -4, and 0, comma, -3. Okay? You could check it just to show you. Plug in x equals -1 on the left. We have -1 minus 3 is -4. We plug in -1, comma, and then we plug -1 on the right, sorry. And you get -4. So you get -4 equals -4. It works. Okay. Now here's the one about the square root. Notice we have a square root, so we're going to begin this. This is 15. I'm probably going to break it here and create it, and then get another video going. And then the other equation is y equals x minus 3. All right. So doing the square root graph, we know it's a square root graph shifted to the left 4 and up 6. It's right there. And then we go to the right 1. Square root of 1 is 1. We go up 1. To the right, 1, 2, 3, 4. Square root of 4 is 2. We go up 1. We go up 1, 2. We go to the right, 1, 2, 3, 4, 5, 6, 7, 8, 9. Square root of 9 is 3. We go up 1, 2, 3. And our graph looks something like that. Okay? That is the square root graph. The x minus 3, 1, 2, 3. We go up 1 to the right 1. 1 to the right 1. Up 1 to the right 1. Up 1 to the... Oh, I don't think it's going to... Yeah. They do cross. It goes off the grid. So I'm going to make this instead of x minus 3... the idea would be that they would they would touch. So I have to bring up 1 to the right 1. I have to add 1, 2, 3. So I'm going to say this. There was a mistake on this. I'm going to make this just y equals x. Now I think they're going to intersect right at the edge. Okay. So here's y equals x. It's just this line right here, right? It has a slope of 1. And so you'll have a ruler. Bring your own ruler, I recommend. There's the graph, and the solution is right there at the point 10, at x equals 10, comma 10. 10 minus 3 is 7. Oh, wait, no, this is... So what I'm saying is I changed the problem to be that. All right? So when x is 10, why doesn't it work out? That's right. I don't know. This is the right idea, but for whatever reason, my brain's freezing on me, and I'm not going to spend much more time on this. So I'm calculating that the solution is 10, 10. If I have time tomorrow, I will go back over because I don't think it's right. Because if you put 10 in for x here, that's the square root of 14, which is not perfect square. So something's up. Okay, so I will look at it. So put a question mark by 15. I don't want to start over. All right, the next one, we're going to solve graphically this equation. It is you have to recognize that the top equation is a circle of radius 4. 1, 2, 3, 4. So you have to feel comfortable graphing. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Now you want to try to make it like that. Try to make it better than what I just did. What's nice about oh, well, it didn't make a circle. Okay, and then x minus 4. So 1, 2, 3, 4. We go up one to the right one, up one to the right one. Ah, look at that. Even though I have a lousy circle, the solution happens to be at, we got two of them, happens to be here at 0, comma, negative 4, and also at 4, comma, 0. Okay, those are the two solutions. All right, then it says solve the system. It's a quadratic. You can use substitution or elimination. I'm going to go ahead and do elimination. And because it's written in such a way, and you have this bottom equation being negative, we just add them, we get 0. Y plus a negative y is 0. And then we have 1x squared plus 1x squared, which is 2x squared, and negative 6 minus 24 is negative 30. So we have 2x squared minus 30 equal to 0. Add 30. Divide by 2. Take the square root. We got the x value. Now the y value, you just got to plug it back in, the x. So I'll plug it into the top so I don't have to worry about the negative sign. So it's going to be x squared. X can either be positive or negative square root of 15 minus 6. Well, the square root of 15 squared is 15. Doesn't matter if it's positive or negative. Minus 6 equals 9. So the solution would be negative square root of 15, comma 9, and positive square root of 15, comma 9. All right. Now, this is the stuff we were working on just recently. Find the following if f of x equals x squared plus 3x plus 4 and g of x equals x plus 2. Oh, come on. Oh, I can't change I was going to try and change the color, but I can't. So, f of x minus g of x. Well, f of x is x squared plus 3x plus 4, and we're going to subtract from it g of x, which is x plus 2. Notice you're subtracting all of the x plus 2. So this becomes, you combine like terms, so there's nothing like with the x squared, so it just stays the same. But now you have 3x minus x. That is 2x, positive 2x. And you have 4 minus 2, which is plus 2. And so that is what f of x minus g of x is equal to. Okay? So that's the answer. Pretty straightforward. Now, notice they switched the order. Now it's g minus f. So that's again going to be g is x plus 2 minus f of x, which is that x squared plus 3x plus 4, notice I put parentheses around it, and let me change the color just so that you understand that this right here is f of x. So now we just have to subtract. So when you subtract, if you can do it in your head, understanding that this negative sign, we're subtracting this, this, and that, I always say add the opposite, so make that minus a plus and change the signs on the inside so you don't mess up your signs. And you have, let's see, we don't even need this now. We don't even need the parentheses because we took care of the negative. We have combining terms. We get the negative x squared. That's the highest power. That's this one. We have x minus 3x is negative 2x. And we have, we have positive 2 minus 4 is negative 2. And so this is g of x minus f of x. Now we're multiplying on c. So c is f times g. Again, f is x squared plus 3x plus 4. And g is, what was g? X plus 2? Yep. I just randomly wrote them down. Okay, so now you have to distribute. So, you end up with x cubed plus 3x squared plus 4x plus 2x squared plus 6x plus 8. All I did was distribute twice. I took x times all three of those, and I took 2 times all three of them, and just wrote them here. Combining like terms, you get x cubed, 3x squared plus 2x, 3x squared plus 2x squared is 5x squared. And then we have 4 plus 8 is 12. Again, 4 plus 8 is 12. And 3x squared plus 2x squared is 5x squared. And notice, I left off the linear term. I left the 6x off. Right there. So my answer is incorrect. There should be a plus 6x. And that's the product. You'll get 2 points for writing this. And then 1 more point if you can get it into that form. All right? Now it says evaluate f of x times g of x if x equals negative 3. Well, I would probably go back to this f of x, the definition, put negative 3 in, and this and put negative 3 in, and then just take the results and multiply them. So it would be, first of all, f of negative 3 would be equal to negative 3 squared plus 3 times negative 3 plus 4. So this equals 9 minus 9 plus 4, it equals 4. So we know f of negative 3 equals 4. Then I would go g of negative 3, and we plug that in, and it's negative 3 plus 2, and that's negative 1. Now, since I know that, I can just multiply them. So, right here, that's going to be 4 times negative 1, which is negative 4. All right, here's the last thing we were covering in this unit. All right, notice they gave you 2 functions, f of x equals x plus 4, g of x equals x squared minus 3, and they want to know what f of g of 5 is. Easiest way is to figure out what g of 5 is by plugging it into g. And that becomes 25 minus 3, so that's 22. So this becomes f of 22. But what's f of 22? Well, f of x is x plus 4, so f of 22 is just 22 plus 4, and it's 26. All right, f of g of x, now we're going to inside of f, which is f of g of x. It's just going to be x plus 4, but instead of x, it's g of x. And what's g of x? It's x squared. It's x squared minus 3. Okay? So f of g of x turns out to be just x squared. Negative 3 plus 4 is positive 1. This is f of g of x. All right, then they want you to reverse it. So now it's g of f of x. All right, so g is x squared minus 3. So this equals x squared minus 3. Well, f is x plus 4. So g of f of x is just x plus 4 quantity squared minus 3. All right? I would argue just leave it. I mean, technically, because it'll be easy because they want you to now evaluate that on part D. Part D would be to put, you can put 3 in for x here, and that's going to equal 3 plus 4 quantity squared minus 3. And that's going to be 49 minus 3, which is 46. All right? You could also, in the original f of x, put in 3 and gotten 7, right? You could also have done f of 3 and gotten 7 and then figured out what g of 7 is. And remembering g is x squared minus 3, so that would be 7 squared minus 3, which again turns into 49 minus 3, which is 46. Either way, it's 6, 7. If you can't see it, I'm doing my hands. Either way is fine. And that's all that you're responsible for on the final. Finally, 20 is something that we're going to do on Thursday, and we're probably going to have to hit it again on when we get back. It's talking about something called an inverse, and they want you to find the inverse and then prove the inverse relationship using composition. So I will just kind of go through it and hem and haw my way through it. First of all, to find the inverse, you instantly switch x and y. So now we're going to rewrite this as x equals y plus 3 over 2. Now we're going to solve for y by multiplying by 2. So now we get 2x equals y plus 3, subtract 3, and we get y equals 2x minus 3. This is the inverse. Again, to find inverses, we switch x and y and solve for y. So in notation, this would be f of x, but we'll put a little 1 on it. That means f inverse of x is simply 2x minus 3. Now, something again we're going to talk about on Thursday, but this is all extra credit. The idea of proving the inverse relationship using composition is because if two functions are inverses and you do a composition, you're going to get just straight up x back, nothing else. All right? So, if y equals x plus 3 over 2, I'm going to say that's f of x equals x plus 3 over 2. So I'm going to do a composition, f inverse of f of x. If we do that, you're going to get x out if it's truly an inverse. All right, again, the little -1 is the inverse symbol. Again, this is extra credit, so I'm not going to beat a dead horse on this. So what does that mean? We do a composition, all right? We figured out that the inverse is 2x minus 3. So we're going to go we're going to do f of f inverse. So f of x, again, is 2x, or it's x plus 3 over 2. But now this inside, instead of x, we have f inverse. And we found f inverse right here by switching x and y and solving for y. So what I'm going to do is put in the inverse here, 2x minus 3. So notice, when this happens, the 3's add to cancel out, and you get 2x over 2, which is x. That's the property of inverses. They kill everything and give you back the input. All right? So that's how you prove it. Again, we're going to really hit this hard on, we're going to talk about it on Thursday, and then hit it again when we get back. All right? From vacation. So anyway, that's it. I hope it was helpful. You have a good evening. Bye-bye.